Hello and welcome to Train Signal. You are watching Writing and Editing Scripts. When I first started using Ubuntu Linux full-time, I printed out a command reference and made sure that every day I tried a few commands on the list. I'd simply fire up a terminal and try out the commands, switches, and all manner of combinations and variations. Even though some of them I never found use for in my daily ruminations on my own laptop, I somehow knew this information might come in handy one day. So when the time came to get my Linux Plus certification, I was eternally grateful for the time that I'd spent perusing the command line. One of the most powerful things you can do from the command line is to combine those individual commands into scripts. Linux administrators rely on scripts to automate some of their more tedious and complex tasks. Scripts is a topic that goes far beyond what we'll cover here, but for the purposes of certification, you'll need to understand some of the basics. So in this lesson, we'll review the components of a script, along with the commands and conditional expressions you can use to increase the complexity. Let's start off with shell script components on the next slide. Thinking back about the company we presented in the course scenario, TechCorp, they will need to transfer all their Windows user accounts to Linux. Now there are tools that can handle this process, which might involve creating the user, assigning permissions, and setting up a home directory, but you could also use a script for this. A script is a text file that contains a series of commands to be executed by the shell. Since most systems use the bash shell by default, most scripts are written in the bash scripting language. But you'll also find that most scripts will run in any of the more common shells like CSH or TCSH. All scripts must begin with the line you see in the image on the screen. $, exclamation point, /bin, /sh, or you'll see also /bash, because sh is a symbolic link to bash. The $, if you recall, represents a command line, but combined with the exclamation point, this indicates that what follows is a script. And the rest is the path to the program that will interpret the script. You'll hear this line referred to as shebang, #bang, #pling, or #bang. After you've written a script, you could run it by typing the shell program name, or bash, followed by the name of the script. But it's preferable to change the file's permission and make it executable. And you do this with the chmod command that we learned in the Managing User Resources with Quotas and File Permissions lesson. The command syntax is chmod space a plus x space name of the new script, where A is for all users and X is for the execute permission, and new script, of course, is the name of a new script. Remember the path variable we talked about in the Linux shell lesson? That variable contains the list of directories where Linux will look to find executable files corresponding to the file names you type at the command line. So with that in mind, if you plan to run a script regularly, it's best to store it in one of the directories in your path. Otherwise, you'll end up typing the full path to the command in order to run it. User local bin is always a good choice. You can include just about any command, internal or external, along with any parameters or options into a script. What you see on the screen is a very basic script that echoes a string and the date on the screen. Let's try this out in real time. Let's move over and launch a terminal window. Applications, System Tools, and Terminal. And to compose our script, we're going to use the Linux community's most beloved text editor, Vi, which we covered in the GNU and Unix commands lesson. So let's type in Vi, followed by the name of the script, and I'll call mine test script, testscript.txt, and hit enter. You'll see that the Vi editor opens in command mode. Now to get it to insert mode, you have to hit either A or I. Another thing to note before we do that is that the name of the file is always displayed at the bottom of the screen when you're in command mode. So let's type in I to go into insert mode. And from here, let's type in the line that belongs at the top of every Linux script. And that is £, exclamation point, /bin, /bash, or whichever shell you might be using, if it's TCSH or CSH. Again, this line is called shebang, or a couple of other names that we've just covered. And let's hit enter. On the next line, we're going to use the echo command, which displays output on the screen. So we'll type in echo, ECHO, space, and in quotes, I'm going to put I love Linux. I love Linux. And we'll close the quote. We'll hit enter again. And just for fun, let's include the date command, DATE, which displays the current system date and time info. Now, do you recall how to write changes to the file and quit from Vi? Well, first we have to exit insert mode, and we do that by hitting the escape key. From there, we type in a colon, and that brings our cursor to the bottom here. Then we type in WQ for write and quit. We hit enter. Now let's type in ls just to see if our script is indeed here. And there it is, testscript.txt. Now the next thing that we want to do is make it executable. And again, we do that with the chmod command. Syntax is chmod space A for all plus X for execute, and the name of the script, which is testscript.txt. And we'll hit enter. Let's type in ls-l, which again gives us the long listing. And we can see for the file we now have execute permissions for both owner, group, and world permissions. Now let's execute the file by typing in bash space testscript.txt. Hit enter. And we can see what's displayed on the screen here is our echo command, I love Linux, and then we have the date and time. You may have noticed that I didn't copy this to a directory on the path, but that's just because we're doing some testing at this point. And that's why I had to type in the bash command in front of the script as well. Okay, let's head back to the presentation. Along with basic commands, you can launch programs with the script. For instance, if you wanted to launch a mail program, you would type in the full path to the program. And if you remember, many system commands are located in user bin. And you can use an ampersand if you want the script to execute the next line without waiting for the first one to finish. But as some programs rely on the output of another in order to execute, you won't always want to use this option. Let's move on to take a look at how to use file manipulation commands in scripts. Another of the neat things that you can do with scripts is to use some of the basic file manipulation commands that we've already learned. Things like ls, which lists the contents of a directory, mv, if you recall, is used to move a file, cp to copy a file. Then there's grep, which locates files that contain certain strings, and you have find, which searches for files based on file name and ownership. You also have cut, which extracts text from a file. Then there's mail, which can actually send email from within a script. Then you have variables or parameters, which are kind of like placeholders for a script. They hold a certain value for when the script runs. Variables are preceded by a $sign and are numbered 0 through 9, with 0 being the name of the script, $1 being the first parameter, $2 the second parameter, and so on. Let's go back to our terminal window and try out a simple script using the cp command and a couple variables. First, let's clear our screen with clear. Then let's switch to our documents directory by typing in cd space documents with a capital D. Now let's create a dummy file using the touch command. All we need to do is type in touch, T-O-U-C-H, space, and think of a file name. I'm going to call it copy test, C-O-P-Y-T-E-S-T. Now let's create our script, and we do so by typing in vi, space, and the name of the script. And let's call it cp script. Oops, cp script vi.txt. Now that vi is open, again we need to go into insert mode, and we do that with either I or A. So I'm going to hit A. Then we'll type in the first line, which you should recall is #, exclamation point, /bin, /bash, or sh. Then we're going to hit enter. Next we're going to type in CP for copy. Then we're going to use two variables, $1 and $2. That's going to represent two variables that we'll use in a moment. So this script will take the two command line arguments. The first is the source to copy, and the second is the target to copy to. So let's quit and save by hitting escape to go back to the command mode and typing in :WQ for write and quit. So to run this file, let's type in, first let's make sure it's here. We'll type in ls, and we'll see that the file is here. Now we're going to run it by typing in bash space cp script, and then we're going to copy the file. We're going to copy the one that we created, copy test, and we're going to copy it to a new file name. Let's call it copy test1 and hit enter. And we got an error because I forgot to include the txt, so we'll use the up arrow, move back over, and add in the .txt. And we'll hit enter. And now let's type in ls, and we should see a new file called copy test1, and we do. Okay, let's head back to the presentation. Now that was a really simple example of what you can do with copy and other file manipulation commands and variables. So get creative, try out some more examples for yourself. But next, let's take a look at conditional expressions. Before we continue on with some more advanced conditional expressions, there are a couple rules that I wanted to reiterate. First, when you assign a value to a variable from the output of a command, be sure to enclose it in backticks. Also remember that variable names should be preceded by a $sign. Next, each script must begin with #, exclamation point, /bin, /bash, or sh, or any other shell that you may be using. This again is known as shebang, hashbang, hashpling, or poundbang. You're likely to see it referred to as any one of these. You'll also want to make sure that your scripts are executable using the chmod command. And finally, if this is a script that you'll run regularly, be sure to place it in a directory where Linux can easily find it. Pick something in the existing path. Now I'll probably break one or two of these rules as we go through our demonstrations, but on live production systems, following the rules is strongly advised. Let's continue our review of conditional expressions on the next slide. Those of you with a programming background will be familiar with the concept of control structures or conditional expressions. The scripts that we've covered so far are deceptively simple. When you get into creating more powerful scripts, you'll certainly want it to be able to make a few decisions and take an appropriate action based on those decisions. You do this with if-then else, and case statements. The syntax for if-then is if space condition, followed by then, followed by the commands that you'd like it to execute, and then it's closed with the fi, or if backwards. The if-then else statement includes an else indicator, which provides a command to execute if the first condition is found to be false, and it also ends with fi. Let's create a simple script using the if-then statement. Let's switch back over to our terminal window. First, let's clear the window. Clear. Now to create a new script, we're going to type in vi and the name of the script, which I will call ifdemo.txt. And again, we open up in command mode with the name of our file at the bottom of the screen. We enter insert mode by typing I or A, so I'm going to hit A. Now we enter the first line, which you should have memorized by now, it's pound, exclamation point, /bin, /bash. And we hit enter. Then we're going to start our if statement with if. Now the way that you do this is really up to you. If you're a stickler for spacing and tabs and all that, you can certainly set this up however you want. But for now, I'm just going to hit a tab so we can move over a few spaces. And we'll type in the find command. I'm going to type in find space /home space -name space and the name of a file that I already know is on the hard disk. And close in quotes, it's user, USER, -manual, MANUAL, -DOC. Oops, DOC. We'll close that in quotes. Then we'll hit enter. I'm going to hit tab again. We'll type in echo, which displays the output on the screen. And in quotes, I'm going to say found it. And then close that with the end quote. Then we're going to go down. We're going to type in else for the secondary condition if this first proves to be false. And hit enter again. And I'm going to type in echo space oops no go. And make sure to enclose that in quotes. Hit enter. We're going to type in FI to close out the if statement. And again, what we have here in the if statement is we're going to ask the script to find in the home directory a file by the name of usermanual.doc. And if it's found, we're going to echo found it. Otherwise, we're going to echo oops no go. Okay, now we're going to hit escape to go back to command mode. And we're going to type in :Q. Now you notice the error on the bottom of the screen here. It says no write since last change, add exclamation point to override. This tells you that you haven't saved the file and says that if you really want to exit without saving, use the Q exclamation point command. Now we appreciate the warning and don't want to do that, so we'll hit the colon again and we'll type in WQ to save and exit. Okay, now let's make the script executable by typing in chmod space a+x space ifdemo.txt and hit enter. Now let's type in ls space -l to see a long listing where we can check the file permissions for ifdemo. And right here we see that we've got execute for owner, for group, and for world. Now let's run the command. I'm going to type in bash and we're going to type in ifdemo.txt and hit enter. Looks like we have a problem in our script, so let's go back and take a look at it. It says on line 5 near else. So let's use our up arrow key to go back and take a look at line 5 and see where we made a mistake. And right here, we forgot our then. We're going to hit I to enter insert mode. Then we're going to enter the then command. So we have an if, then, and else. Okay, let's hit escape to go back to command mode, :WQ to write and save. And now let's hit up arrow again and run the command. And what we can see here is it did find the file in home vhenry documents. And for our test user that we created a few lessons back, couldn't find anything there. So that's when we get the oops no go command echoed on the screen. Okay, let's head back to the presentation. If-then statements work pretty well if you only have a couple options. But what if you have a script that had several possible outcomes? Now you could use a whole series of if-then statements, but that could quickly become quite messy. That's when you want to use a case statement. And this is when you have more than two outcomes, or the condition can be evaluated in several different ways. Basically, the value of the variable is compared to the list of responses within the case statement. The syntax is case space variable followed by the word in. Then you have patterns. You might start with pattern 1 followed by commands, and that line has to be ended with a double semicolon. Then you have a second pattern followed by any commands that you need to perform, and again that must also end in a double semicolon. You end the case statement itself with ESAC, which is case spelled backwards. Let's try out a script using a case statement. Let's switch back over to our terminal window. Now earlier I wrote a script that asked the user where they live in the US, whether it's East, West, South, or Midwest, and it echoes a response based on that answer. Let's go over this script. Let's type in CD and hit enter to go back to our home directory. Let's type in ls, and we see the file name that's casedemo.txt. This is the file that I created. So to view it, let's type in cat space casedemo, casedemo.txt. And that'll let us view the script. The first line again indicates that this is a script. The echo command asks the user which region of the country that they live in. The responses are North, South, Midwest, and West. The response that they enter at the keyboard is read with the read command and stored in the region variable. The case statement takes that variable and compares it to the responses North, West, Midwest, and South. Each line has an open parentheses following the pattern and ends with a double semicolon. And we end the case statement with ESAC followed by just an exit command. First, let's make this executable by typing chmod, C-H-M-O-D, space A plus X, space casedemo, name of the file, .txt. Now let's execute the command. We'll type in bash space casedemo.txt. Let's see, it asks what region of the country that I live in, and I'm going to say West, and hit enter, and we see the echo output on the screen. Let's run that again by typing in bash, and we use our up arrow to bring the command back up. Hit enter. Now let's try north. Hit enter. And we can see again we've echoed you live in the north, which is the Sun Belt. Let's try out Midwest and South just to make sure everything's working properly. So we'll use the up arrow to run it again, and let's type in Midwest this time. And our echo command says that you live in the Midwest, which is the middle of the country. And let's do our last region, the South. Type in South and hit enter, and it echoes that you live in the South and you like warm weather. Okay, let's head back to our presentation. The next conditional expression is a loop, which performs the same action until a certain condition is met. The syntax is for space x in condition in single quotes, semicolon, and do, followed by command, followed by done. The sequence command is often used with for loops. Sequence generates a list of numbers starting with the first argument and goes on to the last, or for x equals seq space 1 space 5. This has the loop execute 5 times, with x incrementing once for each pass. Until is another type of loop, and it executes until the condition becomes true. Okay, I've cleared the screen from our last case statement, and now we're going to try a for loop example. So let's type in vi space, and we'll call it loopdemo.txt. And hit enter. We're going to hit I to enter insert mode, and we're going to type in our first line, which is #, exclamation point, bin, bash, and hit enter. Now let's enter our for loop. So we're going to type in for space x in, then we'll need an open curly brace, 1.3, which tells us that we're going to execute that from 1 to 3 times. And let's close the brace and go to the next line. Next line is do. And next line we're going to have an echo command. We're going to type in echo space quotation mark, I am the script master. Close that with the quote. And then we end the for loop with the done command. Okay, again we have our opening line here, which tells us this is a script. We have the beginning of the for loop, which says for x, we're going to repeat this action from 1 to 3 times. And the action is to echo the command, I am the script master. Okay, let's hit escape to go back to command mode. And we're going to type in #WQ for save and quit. Okay, now let's go ahead and make this executable with the chmod command. A for all plus x space loop demo.txt. Okay, let's do an ls -l to make sure our permissions are applied. And here's loop demo, and we have execute for owner, for group, and for world. Now let's execute the script by typing in bash space loop demo.txt. And we see that it echoed our command 3 times, or our statement rather, 3 times. I am the script master. Let's take a look at another conditional expression, functions, on the next slide. The last of the type of conditional expressions that we'll cover is functions. Functions are part of a script that performs a specific subtask and can be called by name from other parts of the script. Functions are represented by parentheses, and they have commands enclosed in curly braces. Let's try out a script with a function. Let's switch back to our terminal window. Now we're back at our terminal window, and let's create a script called fscript. To do so, let's type in vi space fs script .txt. Okay, we're going to hit A this time to enter insert mode. And we're going to type in our initial line, which is # exclamation point /bin /bash, and hit enter. Now let's create a function by typing in function with the parentheses and the open curly brace. Actually, we forgot to put in the function name, so let's enter that now. The function is going to be called hello. And we'll hit the end key to go back to the end of the line and hit enter. From here we'll just do another simple echo command. So we'll type in echo space howdy. And we'll close the curly brace. On the next line, we'll close it here. And you can also do that on the previous line as well. We're going to end it with the hello function name. And for here we're ready to save it, so let's hit the escape key to go back to command mode. I'm going to hit WQ for write and quit. Let's go ahead and make it executable with the chmod command. chmod space A plus X space fs script.txt. And ls-l rather, will confirm that we have the right permissions. And we do. We have execute for owner, for group, and for world, as you can see here. Now let's execute the script with the bash command. Bash space fs script.txt and hit enter. And we can see that our echo command worked and we have howdy printed back on the screen. Okay, let's go back to the presentation. And that concludes our lesson on writing and editing scripts. Let's review what we've learned on the next slide. We've just barely touched the surface of what you can do with scripts. Now, some would argue that this is a skill that takes at least a year to develop fully, and I certainly wouldn't argue with that. Certification candidates should understand the basic structure, syntax, commands, and expressions that can be used to compose a script. To recap, in this lesson, we learned about the components of a shell script, some of the commands that can be used within the script, and how to use conditional expressions to introduce true, false, and other multiple option scenarios. Thanks for watching, and I'll see you in the next lesson.